Hello everyone, welcome to the course of Digital Logic Design. In today's class, we are going to convert binary value to the decimal, octal and hexadecimal. So let's take the problem. Convert binary number 110, 110, 1100 to decimal, octal and hexadecimal. So this is the problem we have. So let's take the question. Given number is 110, 110, 1100. Okay. Let's convert this into decimal. Okay. So in order to convert this binary number into decimal, we need to take the powers of 2 from the right side. Okay. LSB bit. So this can be 2 power 0. This is 2 power 1, 2 power 2, 2 power 3, 2 power 4, 2 power 5, 2 power 6, 2 power 7, 2 power 8, and 2 power 9. Okay. Now let's rewrite this. So this can be written as 1 into 2 power 9 plus 1 into 2 power 8 plus 0 into 2 power 7 plus 1 into 2 power 6 plus 1 into 2 power 5 plus 0 into 2 power 4 plus 1 into 2 power 3 plus 1 into 2 power 2 plus 0 into 2 power 1 plus 0 into 2 power 0. This is how to represent the powers of 2 with respect to the binary number. Now, so 2 power 9 will become 1 into 2 power 9 will become 512 plus 1 into 2 power 8 will become 256 plus 0 plus 2 power 6 is 64 plus 2 power 5 is 32 plus 0 into 2 power 4 is 0 plus what is the 8? We have 2 cube is 8 plus we have 4 plus 0 plus 0. Okay. So if you add all this, we get an answer 876. Okay. So the binary 110, 110, 1100 of binary is converted into decimal format 876. Okay. This is the answer. Now let's convert the same binary number into octal representation. Now, given number 110, 110, 1100 to octal. Okay. So let's convert that into octal. So note, for the octal representation, consider group of three bits for octal representation. So whatever the binary number is given, that should be considered with respect to group of 3 bits. So let's write down the binary number first. 1, 1, 0, 1, 1, 0, double 1, double 0. Okay. So from the right side, consider 3 bits in a group. This is one group. This is the second group. And this is the third group. And the last one bit is 1. Okay. So the binary 1 goes to 1. 101 binary will be having 5. Again 101 is 5. 100 is 4. Okay. So this is the answer in the form of octal conversion. So 110, 110, 1100 of binary is giving 1554 of octal representation after the conversion. Okay, this is the answer. Now let's convert this same number into hexadecimal. Now let's take the same number given number 110, 110, 1100 of binary into hexadecimal. Okay, let's convert this. Here, note. In order to convert this particular binary number into hexadecimal, we need to consider group of 4 bits of the binary in order to convert into hexadecimal representation. Okay, let's take 4 bits. So what is the number given? 110, 110, 1100. So these are the 4 bits and these are the another 4 bits. These are the 2 bits left. Okay. So 11 will be giving the number 3. The binary 0110 will be giving the number 6 and the 1100 will be giving 12. Okay. So 12 in hexadecimal can be considered as C, right? So the answer is 36 C. So let's conclude it. 110, 110, 1100 of binary is equal to 36 C of hexadecimal. Okay. So this is how to convert the binary number into hexadecimal. Okay. Now let's take another binary number with the decimal point. Let's see how to convert that into both decimal, octal, and hexadecimal. Let's take the problem that convert 111, 00, 111, 00.011 into decimal, octal, and hexadecimal. Okay, let's see how this can be converted. So given number is 111, 00, 111, 00.011. So let's convert this into decimal first. Okay. So little bit change, a slight change will be there according to the previous operation. Let's write the number clearly. 1, 1, 1, 0, 0, 1, 1, 1, 0, 0, point 0, 1, 1. Okay. So whatever the numbers are there before the decimal point, consider those with respect to the powers of 2. Okay. And whatever the numbers are after the decimal point, same, consider them also with respect to powers of 2, but in negative terms. I will show you how. So for this, it is 2 power 0. This is 2 power 1. This is 2 power 2, 2 power 3, 2 power 4, 2 power 5, 2 power 6, 2 power 7, 2 power 8, 2 power 9. Okay. And after the decimal point, whatever you have, consider it as 2 power minus 1, 2 power minus 2, and 2 power minus 3. Okay. And how to represent this? Same. 1 into 2 power 9 plus 1 into 2 power 8 plus 1 into 2 power 7 plus 0 into 2 power 6 plus 0 into 2 power 5 plus 1 into 2 power 4 plus 1 into 2 power 3 plus 1 into 2 power 2 plus 0 into 2 power 1 plus 0 into 2 power 0. After this, what you need to do is followed by plus 0 into 2 power minus 1. This can be written as 1 by 2, right? So continued by plus 1 into 2 power minus 2 plus 1 into 2 power minus 3. This is how to write. Now, let's see all the terms. So 512 plus 256 plus 128 plus we have 0. We have again 0. 1 into 2 power 4 is 16. 2 cube is 8. 2 square is 4 plus 0 plus 0 plus 0 plus 1 into 2 square plus 1 by 2 cube. Okay. So if you calculate everything, the answer what we get is 924.375 of decimal number. This is how this type of binary is converted into decimal. Okay. Now let's see how this binary number is converted into octal representation. Okay. Octal representation. Let's see the given number. Given number is 11100.011. Okay. So as we are converting that into octal number, consider 3 bits in a group. Okay. Same like the previous problem. So these 3 are one group, these 3 are one group, these 3 are one group, and this is one group. Okay. So from right to left, we are considering before the decimal point. And after the decimal point, we need to consider from left to right in this manner. Okay. So what is 1? 1. What is 110? 6. What is 011? 3, 100, 4, and 011 is again 3. Okay. So the octal representation of 1110000.011 of this binary number is 1634.3 of octal. This is the answer after converting that into octal representation. Now let's see how the same number is converted into hexadecimal. So again, given number 11100.011, converting it into hexadecimal. Okay. So we all know, right? A hexadecimal conversion means we need to consider 4 bits from right to left. This is one group. This is one group. This is another group. So right to left. And for the value after the decimal point, we need to consider from left to right. So what is 11 here? 3. What is 1001 here? 9. And 1100 is 12, right? And 12 can be represented in the form of C. And coming to the value after the decimal point, 011 is nothing but 3 again. Okay. So what is the answer? 39C.3. Okay. So let's conclude it. The binary value 111001100.011 of binary is equal to 39C.3 with respect to hexadecimal. This is the answer. This is how to convert the binary numbers with and without decimal point.